Salam Muhammad. I have two Muhammads, Si Muhammad and Muhammad.
Hi.
Hi, good. Okay, well, we have as you all know, I'm recording these classes. So today we have a full class. I mean, we have everyone almost is here. And so we're gonna start. So Mohammed, I'm gonna repeat what we did last week, and I'm gonna go over DC motor, stepper motor a little bit in details. But this serial communication, I think it's very important, and I want to go over what we did last week. So last week we built this circuit, okay, and we used a potentiometer. This is basically, you can think about it as a voltage divider. Like this one is connected to 5 volts, and this one is connected to 0 volts. And this in the middle, the pin in the middle is what they call a wiper. It depends how, when we turn this dial, that voltage, it can go from 5 to 0 volts. So it depends where we stop. And I called it last time also, it's either voltage divider or a variable resistor. For now, the only thing that you need to know, it has 3 pins: terminal 1, terminal 2, terminal 1. You can connect these to like ground and positive side. And the middle one is what we're gonna connect to A0. And remember we said from A0, all these 6 pins here, from A0 to A5, these are analog input pins, okay? We want to see, once we dial and we change the value here, as I will do in simulation, we want to see what is the voltage drop. That's what we call. What is the voltage drop as we change this? And actually, we're going to see it also with our PC using serial communication, okay? And remember, we did simulation last time. We had 2 LEDs. We had one LED connected to a potentiometer, and this LED, the value actually, as you will see in the code, even though it's connected to pin number 3, but the value of A0, okay, this is an input. We're going to be setting A0 as an input, so we're going to be reading the voltage of this pin here. Is going to be written into A3, as we will see in the code, okay? Let me just show you the code. So remember this circuit. Here is the code. The code basically go by creating a variable, okay, called integer. The first variable, since it is potentiometer, just call it pot pin, but you can call it my pot. You can call it whatever. It's just a name, variable. And then we said this variable, we set it to A0. You see this? Because we're trying to read the input voltage on A0, okay? And we created another variable, and we called it pot value, okay? We just declared the variable, but we didn't initialize it because we were gonna give it a value later on. And then we created another variable called lead pin, and we set it to 3. So this one was set to A0 because it's connected to A0, but the other one, you see, signal that we're gonna output to this LED is connected to pin number 3. So we call this variable pin lead pin 3, and we give it a value. See that? We call it lead pin, and we give it a value of 3. So we're telling basically the Arduino, this is the pin what we're using, okay? And here the same thing. For the pot pin, we're using pin A0. You can actually write 0 here, and it's fine also, okay? But just to be more consistent, just say write A0, so you know it's A0 pin, okay? And then after this, after initializing and declaring our variables here, now it's the void setup. So there's always two functions. One is to set up our program, and the other one is really kind of to create this void loop, kind of to execute the program. So there's always these two functions in any code. Okay. So now we're gonna set up the mode of our pins. So by writing the statement pin mode, okay, and lead pin. What is lead pin? Lead pin is pin number 3. See that? So when you write the variable here, it's just like you're saying, hey, pin number 3, make it as an output. That's what it means. And you gotta finish this statement by semicolon. Okay. Now we have to set up A0 too, but A0 we're reading, so we are actually it's an input. So we said path pin. See, that's path pin, which is A0. Actually, you can also write here A0 if you want as an input. Okay, so this is how we set up our variables. Okay. Now this is what's new. I mean, we've done this kind of codes before, but this is what's new for you, and this is what really I want to that's why I want to go over this again one more time. It's this serial communication, because your laptop, if I go back here, let me close this one. See, through this USB, data is being passed to your laptop. From laptop, go to the USB through the serial communication that we talked about last week. Hey, by the way, did you watch that video I made, lesson 5?
Yeah, I did watch.
Yeah, because I kind of in the lecture I did not have that digital pen, and I couldn't really explain much better. So I kind of added a few things. So if you didn't watch it, please do go ahead and watch it. I explained very well serial communication and a few other things. Okay. So when you write a code, sometimes you want to see what's passing between your laptop and the microcontroller, this chip here. And serial communication, basically, it will let you see that. And I'm going to show it to you right now, not in Tinkercad because it doesn't have serial communication, but with the Arduino IDE. Okay, so let me continue. So basically, let's just do a simulation, and then we're gonna go to that hardware part. Okay, with that. Well, let me finish the code first. Okay, so serial to this serial library, basically, Arduino has a lot of libraries, and one of them is this serial library. And this statement, all it does is telling the PC, hey, if you want to talk to me, you can talk to me at this speed. That's all it is, you know. This is, remember, because with serial communication, you have to set up the baud rates, okay? And also there's a framing format. I talked a bit about that last week. Remember that stop and stop bits and start bits. So communication, when someone is listening, he's receiving. Like when you talk to someone, you don't just one person talk, the other person talk. No one is going to hear each other. So the same thing with serial communication. It creates some kind of protocol between two parties, between a listener, which is a receiver, and a transmitter, which is the person who talk. Okay. So that, and I will show you, actually, you can change this value to other values. But actually, the one I use, and it works always good. It's this default value, which is 9,600. If the bit rate, we can talk about bit rate and baud rate another time. But just think about this as the speed, okay, of the bits, how fast they go through that wire, okay. And then the void loop. This is the next block of code that you always have to set up. So let's just read the, as you say, as I mentioned before, whenever you see a forward slash means this is just comments. And I'm just going to read this. Read the value of the paths and store it in a path value. So basically, since we're dealing with analog, remember the A0, it's an analog signal. It's not just high and low, 5 volt and 0 volts. It's a voltage that is actually, that's what analog means. It's a voltage that vary between 5 volts to 0 volts. So it could be 4.3, could be 4.7, could be 3.9. Okay. Even though we say, you have to keep in mind, even though we say analog signal, but it's really still digital. Okay. Because with computers, we cannot really create 100% an analog signal. We digitize it, okay? But that's not a topic. I don't want to confuse you. But just think about on your background, when you say analog, it's really digital, but the values are not just 0 and 1, binary numbers, or 5 volt and 0 volts. It actually discrete values, okay? Does it make sense, Marwan? Mohammed?
Yeah, I understand.
Okay.
Yeah.
Okay, that's good. Yeah, because I know this is a little bit confusing topic, but just keep in mind, even though we are talking about analog, it's still digital, really. And there is what they call analog to digital converter, okay? It will convert. Sometimes, let's say in our case, as I will show you, it's using 10 bits, okay? And if you do 2 to the power of 2, because you have binary values, either 0 or 1. If you do 2 to the power 10, it will give you like 1000, I think it's 1024. So these are the values actually that the analog to digital converters, okay? From 5 volts all the way to 0 volts, you have all these pieces of voltages, okay? But there's not an infinity, but only limited number, like discrete number. So can anyone tell me from 0 to 1 how many in an analog world, how many actually numbers you can get from 0 to 1? Or let's say from 3 to, let's say from 11 to 12, from 11 to 12. So I don't confuse you with binary.
5.
From 12, let's say, these are numbers. From 12 to 13, how many values do we have in the analog world? Infinite number. You see?
But it's like you're saying like you can get like from let's say for example from 11 to 12. I mean, how can we get like infinite number?
So there is remember you studied real numbers, and like you have decimal values, like from 11,
yes.
just to not confuse you, from 11 to 12,
Yeah.
I can say 12.1, 12.3, 12.44, okay?
Yeah.
So there's an infinite number. But with digital world, we kind of, even though we talk about analog, but it's not really an actual analog. It's discrete values, specific values that we use based on how many bits we use to represent that range. Make sense?
Yeah, I understand now.
Okay. Yeah, there is another topic we can talk about, like binary numbers, decimal values. This is really important also in digital world, hex values, because sometimes you use a hex value, okay, in your code, and you need to know how to convert them. But let's not get there now, okay? I'm sorry, I'll just start talking about other stuff, okay? So for now, what we are doing, we are reading, okay, the path value. This is a variable that we created, okay? Remember here, path value, okay? And we give in this value whatever we read. You see this analog read? This is the function that you want to use when you're using an analog pin, okay? You don't use digital read or write, use analog. This is the statement, okay? And then the path pin, see the path pin, which is A0. Remember the path pin, we said path pin We could have really written analog read A instead of path pin A0, just like that, and our code will work fine. Okay, but it's better to always create a variable and use that variable. You know, it's much better. Later on, maybe you'll see why. Okay, so for now, let's just put it back here. Just want to show you. Okay, now we want to turn the LED with the value of the path value. So what you do analog write. So you put the LED pin, which is 3, you see, and then you put the value. Remember I talked to you about that we're turning this LED from the value that we get from here. Okay, so this input that is getting into here, it's coming from actually this pin. So let's do we're gonna start simulation, and I'm gonna dial this, you see. You see now the values are not just like two states, bright or zero. See, it goes gradually. See, that's like analog. You notice that? And it dims.
Yeah, I see.
Yeah.
Yeah.
All right. So this is what I want to show you really. I know you know how to do this now, but it's the serial communication part. That's unfortunately we cannot do it with Tinkercad. We have to go through our hardware. Okay, let's see if you can see. No, can you see that? So
yeah,
the same circuits, okay, that we built with Tinkercad, the same thing. We can actually turn this. Oh, hold on. Oh, of course, you cannot. If you are not plugged, you're not gonna see anything. Always make sure power is plugged. So I'm gonna plug this here, and note that when I go down, I dim my LEDs. See that? I'll probably burn this one. But what I want to show you is right here. Let's go to Arduino, and then serial communication. Can you see my IDE?
Yes.
Okay. It's the same code that I was talking about, the same thing, but it's on the IDE now. Okay. And see this button here, which says serial communication or serial monitor. This is normally what you click on. Okay. And then when I turn this, notice the values start increasing from, normally this should start from 0, but this is limited due to the hardware. You should go, since we're using 10 bits, it should go to like 1024, but that's good enough. Okay. And these values, let me go back to the code now. Okay. I put this on the side. It's this serial library that actually making us able to see what values we get on our potentiometer. Okay. And then here you can, beside, you write this first, and then you write serial print. We're printing path value as a you see that? And then we go here, print ln to make it next line. Okay. And if I go back, hold on, let me go back here. See, serial print path value, the value is printed. We make space here so we can just like we made space here, okay, between quotation here. And then here there's a difference between print the value. Actually, you see the value, this is the actual value of the variable, and this is forgot the name of that. What is the word I'm looking for? Anyway, when it comes to me, Getting old. So if I move, notice if I take this L in here, take it out, and I have to push this again. Notice now it's one line. You see that? Everything is coming in one line. Okay.
Yeah.
Yeah. So if you want to make like a nice table and you don't want everything to come in one line, you write here LN, next line. That's what it means. You know, like a carriage return. Okay. So I'm gonna push this again. I mean, I'm gonna upload it when I say push.
Wait, I'm sorry to interrupt you. Can we do just like
See that?
slash n line? Yeah. Can we do just like slash n or like end line in the end?
No, I mean, programming wise, sometimes
Oh
the
yeah.
commands are the same in some, you know, from you go from one programming language to another language, but it doesn't mean all syntaxes are the same. Okay,
Yeah,
so you
true.
gotta respect each programming language have their own syntax. So
Yeah.
if it's not used, it's not gonna work. But we can try. I mean,
Yeah.
you can. It's good to always try things. Okay.
Yeah, because
So,
I always use like this the slash n or just like end l.
but
I never like
for
use
Visual Studio, you said.
yeah for visual like always we only do like the slash n and or this one I sent on the group chat end l. Like for people that just started like they just have like some lines for like self they just do like end l. But if you have like a lot of lines you can just do like backslash and
I can
yeah
try it, but for this class, I can try it later on and see
yeah
Mohammed. For this class,
yeah okay
we starting from scratch. We want to just make sure that we learn one thing, and then we can
yeah
move to more like how we can do this better and differently.
yeah
Okay.
yeah thank you.
So yeah, thank you. So let's go back to okay here. So let's just keep for now ln, okay, and then I'm gonna push it and look at the serial monitor. So this serial monitor is really important when you troubleshoot, when you want to see actually values are passing or not. So it's good to have. That's why I want to go over this one more time. Okay. Everything is good, Marwan, Adam, Mohammed, Yasin.
Yes, of course, of course.
Okay.
Yes.
Sounds good.
Yes.
So okay, so this is try to do it when you have your own time. Connect, use this circuit here, but build it actually with your actual hardware. I gave you a potentiometer. You have the LEDs. You have your Arduino, and I'm sure you can do that. Okay. And I'm gonna write this document. I think it's already did it. It's in that Google class that I share with you. Okay. So after this, I want to go. Let's stop simulation. Okay. We're gonna talk a little bit about motors. Okay. And there's all kind of motors. There is let me show you through the camera. Let me make sure. We have what we call a stepper motor. You see that? It's a little bit bigger. This is what you use in 3D printer machines, in the CNC machine. And one of the projects we're gonna build is to use 4 of these stepper motors, and we're gonna build a CNC machine. You know what CNC machine? CNC stands for
No.
Computer Numerical Controller, and CNC machine is used for engraving. Like let's say you want to in wood engraving, or even in laser. You know, if you're using laser, you can, like for wood, we're gonna use Dremel. You know, Dremel, that bits that keep turning and making holes. We're gonna use that and control in an X and Y, Z movement. We can actually control that bits. Okay, so I'll I don't know if I saved it here. Let me show you what I'm talking about quickly. 1 second. Oh, where I have it. Hey, by the way, did you install Fusion 360?
No, not yet.
Yeah, this software, can you see it? Autodesk Fusion
Yeah,
360?
yeah, we can see.
Okay, so this soon, maybe not the next class, but maybe in couple of classes, we're gonna start talking about how to design, 3D model using Fusion 360. Okay, this is the software I'm talking about. I just want to show you something quickly. I don't know if I have it here on my other computer. I'm not sure. All right, guys, I'm sorry. Anyway, don't want to waste time in looking for this file. Let's talk about this another time. But it's good that I mentioned. I want you to install. There is I think 30 days trial. It used to be free, but last time I checked, there is a 30 days free trial of Autodesk Fusion 360. Very powerful. This tool, you can build anything. I mean, you can design 3D model of mechanics, like let's say a car part, anything that you can think about. It's a very powerful tool. But I'll talk about this next time. Don't wanna. Okay, let's go back here. So no Fusion 360 for now. Yeah, so with the stepper motor, it's not important. It's not really used for turning fast or speed. It's more for positioning. This one actually you can use for, as I said, for like robotics, for CNC machine, for like anything that require like even elevator movement. You go from first floor to third floor. You want your motor to stop at certain position, the stepper motor, and we're gonna talk about this today. Okay, then you have like the let me. Remember this motor, Marwan, that you have? This is called geared DC motor. It has some gear inside, and it reduces the speed. But when it reduces the speed, it will increase the torque, because we need this to kind of carry the weight of the car and turn at the same time. So we use this motor. And there is another motor I have here. See that? This is what I gave you. It's small motor. This is a simple motor. But it's also called DC motor. Okay. And if you know how to control this, you know how to control this the same way. And we're gonna see this example. Okay. So let me go back to. I made a small lecture here, or small documents, and just tell you the list of material that we're gonna need. So basically, they are right here. We're gonna build this circuits, and I'm gonna give you time to build it, including you, Mohammed. I know you don't have the hardware, but you can use Tinkercad. Okay?
Yeah, okay.
Use Tinkercad. I'm gonna keep this, and I'm gonna put this also in the that share drive, the Google Class. Okay. What you're gonna need is this L29 3D chip. This is basically a DC motor driver. See, without this, you won't be able to actually drive. This require a lot of more currents. Okay, and 5 volts. It's not enough from Arduino. So like I'm using 9 volts here, but actually you can put anything from 5 to 36 volts, and this small chip will be able to withstand that voltage. Okay, if you have like bigger motors that actually operate at 12 volt, 24 volts, just you can control them with this tiny little chip. Very, very important chip right there. Okay, you're gonna use it a lot. Okay, so remember the name L29 3D. Okay, and I'm gonna show you the wiring diagram for this. I'm gonna go back here. Just 1 second. I come back to this one. Okay, and this document I start writing it today. I'm gonna put it in the share drive. Okay, this is the chip I was talking about, L29 3D. Okay, and here it shows you how the pins are connected. Let's go to a better diagram. Okay. I have another diagram for you here. Okay. Yeah.
Excuse me.
Sure.
I have all the hardware for that, but I don't have enough wires to build it.
Oh, sorry about that. Okay. Yeah, that's not good. I mean, it's good. It's just I'll see your father next time, and I'll give you, and I'm sure Adam is not gonna have enough wires, and also Yassine. I'm sure I'll pass some hard some. So for now, what you can do, try to build it on Tinkercad. Okay.
Okay, I'll do that.
Yeah, just build it on Tinkercad for now. Okay, until you really understand how things work. So I'm gonna leave this for you, for Mohammed, Yassine, see Mohammed also, Adam.
Yeah, thank you.
Yeah, should we maybe continue with the class, and this document is gonna be, you can build it later on. I think it's better because we always have like 1 hour, and then if I keep waiting, then just follow me for now, okay? Next time,
Okay,
probably I will have the document ready before the class so you can build it. Well, actually, I did share with you the go to, I think I did, in the email. Did you receive my email?
I received an email.
Yeah, it's on the email. Click on that link. You should, if you click on it, you should get this diagram here. Okay.
Yeah, I already did.
Okay. How about you, Adam? Or Marwan? You should get. See this one. You should get this because I shared this with you. So you don't have to build it. But it would be good if you can build it. Okay, now let's see how actually this thing here work, okay? I'm gonna go to the code. So as I said, this chip here control DC motor, and you know, for if you want to just control this directly with Arduino, you won't be able to, because this will require more amperage. So I'm using a 9 volts, and I didn't just use this from my head. Let me show you the diagram. This document I'm sharing with you. See here, if you go down here, right here, you see pin number 8. Just remember this, there is a notch in any IC circuit. These are called IC circuits, integrated circuits, okay? In any IC circuits, most of them, they will have a notch here. So always to the left, that's where your pin number 1. Pin number 1, 2, 3, 4, 5, 6, 7, 8. And you continue 9 all the way to 16. So this is a 16 pin. Sometimes you will have a notch right here. So that indicates pin number 1. So it's very important to know position of pin number 1. Okay. And so this is what I put my 9 volt right here. Okay. And see here, it's telling me to connect this to pin 15. If I go back to my diagram, you see here, I'm connecting this pin. Let me zoom in. You see this pin here? It's connected to my 9 volts, okay? And this pin, it says connect to 5 volts. It is connected to my 5 volts. You see? Everything here is connected to, here's my 5 volts. If I go back here, see this 5 volts? It's coming here. And now When I connect this to here, all these are connected to 9 volts, to 5 volts. And then I kind of extended that to this side. You see that? Means these are connected to 5 volts also. Okay. And then this pin here and this pin, they have to be enabled. Means they have to be high. So I put them in 5 volts. If I go back to documents, you see here, it says enable pin. But don't worry about this. Once you know how you understand this, you can actually use this for all motors. Okay. So just be patient. Use it once. Try to understand the lead of the motor. They are connected to pin number 3 and number 6. So this chip here can control 2 motors. You see motor 1 and motor 2. So A side and B side. Okay. So the same. So this one is connected. This is the outputs. Okay. O stand for outputs. You see here, and if you can you want to see here, this is a better diagram here. You have pin number 3 and pin number 6. Their output to the motor. This is what's gonna drive the motor. So if we go back here, let me go back here. You see, I'm gonna zoom out. See, this is connected to pin number 3. You see that? This is pin number 3. And this one is connected to pin number 6. And doesn't matter. You can actually, there is no, you can actually swap this. This one can go here or this one can go here. Doesn't matter. There is no polarity on this one. Okay. The same, the other motor. You see this motor? The same thing. So we have this pin here and the other pin goes here. So one pin here and the other pin is right here. Okay. So you follow this diagram and follow my schematic to understand really how this can control the 2 motors. Okay. So if I go back here, so from pin number 3, if I explain you this motor, the same thing will go for this motor. Okay. So we're using pin number 3 and pin number, you see that? Pin number 6. So we have 1, 2, 3, 4, 5, 6. Okay. This is how we drive this motor. These pins are being set as an output. Okay. But then pin number, I think this is 9, so this is 8. So pin 8 and pin number 2, these are set up as an input into pin 9 and 8. Let's do simulation. I'm gonna go to the code and you're gonna, I think, understand much better how this one works. So let me just do this simulation first. Okay. I'm gonna start simulation. Note this, they are turning. See that? And this is the speed, revolution per minute. That's what RPM stands for. Okay. Now we're gonna go to the code. Oh, let me show it to you actually in the actual hardware. You see here. That's good. Okay. Now let me show you another circuit. Okay, now let's go to the Arduino, and here is the code, the same code. You always go to tools, choose your Arduino. So we're using Arduino Uno, and then use your serial ports. And I have COM3 and try to upload the code here. Oh, here we go. Can you see that?
Yeah, we can see.
So I'm driving. See this little chip right here?
Yeah, we can see. We can
Yeah,
see.
this
When
little
there's like
chip is driving this motor right here. You see? Okay.
yeah, yeah,
And I'm
wow.
actually
Yeah.
driving even the small motor too. So this one is turning. Can you hear? Yeah, let me zoom in. This is the motor that you have, Adam. So it's turning. Now let's go to over the code. Okay, I'm gonna stop this one. Okay, it's the same, basically the same. Oh, not this one. Oh, I lost it. Let me open again. Okay, it is the same configuration, okay? The same diagram. So I shared this with you, try to build it, and I'm gonna give you more jumpers you can use once I meet your parent next time. And see, Mohammed, I'm sorry, you have to wait until I bring you this, but you can actually use this.
No, it's all good.
Yeah, you can, the same,
Cook at yeah.
you will have the same experience. You know, you got the driver here. I will share the document. I will showing you this document with you here, so you can follow actually the connection diagram. Make sure that you understand. I wrote some,
Yeah, yeah, thank you
you
so
know, I
much.
explained every pin here what it does. Okay, and some literature about the driver right here. So basically just saying, hey, this is a chip that can handle up to 36 volts and 600 milliamperes. And it's really also known as an H bridge. This is just another name. So basically with this chip, you can reverse currents and make the wheel of the motor or the shaft of the motor go backwards and forward and reverse, just like driving a car. Um, anyway, so read through this. Now I'm gonna go through the code before we end this session, and I'm gonna leave the stepper motor for next time to really spend more time on stepper motor. I don't want to rush it, okay? So this is very simple code, okay? Very simple code. So all I did is create 4 variables, and I call them type constant. You know, you can actually do integer if you want to. So the first one is called left forward, okay, and I give it. I set it to be attached to pin number 9, and then the other one is left backward, and I set it to 10. Then the right. So every wheel has 2 movements. It's either going forward or backward. You see that? So you can go forward or reverse. So each the pins of the motor, by actually making one high, one low, you can actually reverse their polarity. Either they can go forward or reverse. Okay, that's why we created the 4 variables. So actually 2 variables for each motor because of that phase shift, because of the movement, either forward or backward. Then we set up all our pins to be outputs because we are driving a motor. So everything should be out, okay? So that's why we set every pin to be outputs. And now, okay, to go, we're gonna try actually this thing, okay? So to go forward, we set both wheels to go forward, we set them high. And then the backward part, we set it low. Did you see that? So this is one wheel, okay? This is one motor. When I say one wheel, means one motor, okay? So we set the pin left backward to be low because we want to go forward. The same thing for other motor or wheel. We set it to go forward, and then so we set it to be high. Okay, let's say we want to go rotate 2 seconds forward, 2 seconds backwards. So what we have to do? All you have to do is do a delay. Okay, delay function, and then you just put, let's say, remember we do 200 milliseconds. Okay, 200 milliseconds of delay, and then we go back here and we copy these. Okay, and then, but this time, guess what? Who's gonna tell me what should we do to go backward and reverse? If we keep this high, do you think we're gonna go reverse or backward? So we're gonna go forward. So we have to make this what? We have to make this low. Oh, not there. So I'm just gonna copy and paste. All right, copy. So we're gonna make this low, but this time we're gonna make this high. Okay. So we're gonna make this high. Okay. Then we're gonna make this low, and then we're gonna make this high. Oh. Okay. Now let's do star simulation. Okay. Normally you should see it. Actually it does. You just have to pay attention to the rotation. It goes 2 seconds one way and 2 seconds the other way. Can you see it? It's hard to see because of the gray and white here. Everyone, can you see it?
Yeah, I can see.
Okay.
I can see.
So, you know, play with this. I want you to play with this, with the code also. I'm gonna stop simulation here. Play with this code, play with the other project, and we do next week. We're gonna start talking about stepper motor, and I'm gonna introduce you. There is a project that I want to build on that CNC machine. I'm gonna also do Fusion 360. Try to install that software also. Okay, we can start playing with it. Everyone is good?
Yeah.
Okay.
Yes.
And
Yes.
yeah, and just talk to your father, Marwan, and I'll see. Actually, when I meet him, I'll give him the rest of. I'll give him some. I have some.
Yeah. My dad said any day works.
Okay, sounds good. I'll give. I have few wires. I'll pass them to you. You too, Mohammed and Yassine. And of course, when I see.
Yeah, thank you so much.
Yeah, Adam, I'll give you some more wires also. Okay.
And he said if you have time today, we could pick it up today.
Today, probably not. But if I am in that area, I'll let him know. I might be there. I'll give him a call.
Okay.
Okay. All right. Well, have fun, and I'll see you next week. Okay.
Yeah, thank you so much.
You're
Thank
welcome.
you so
Thank
much.
you.
Bye.
Thank you.
Thank you.
Bye, everyone.
Bye.
Bye.
Bye.